Welcome back to Atomo Tutorials, and for this video we are taking a look at one of the most important aspects of chemistry, for calculations especially, something known as the Avogadro constant. And the Avogadro constant is this number here. Now, depending on how familiar you are with standard form, you should know that this is an incredibly large number. If we were to write it out, it would be 602 with 21 zeros on the end of it. So it's a big number. That's Avogadro's constant. I'd like you to remember it, keep it in your mind for a second while I introduce something called the mole. Now the mole is just a word which represents a number. In this case, this number, the Avogadro's constant. So we know that if we say a couple, we mean 2. We know that if we say a dozen, we mean 12. It's the same concept. If we say we have a mole of something, what we mean is we have 6.02 times 10 to the power of 23 of it. But why do we need this number? Well, in chemistry we tend to measure the amount of something in moles. This amount could be the number of atoms, ions, molecules, and it's convenient to use moles because even the smallest physical quantity of a substance will contain a huge number of particles. So instead of writing out an incredibly high number for how many particles of, say, compound A, for example, we have, what we would do is say, oh, we have 3.5 moles of compound A, and it makes things slightly easier. But something incredibly useful about this is what is written here. And it says that the mass of 1 mole of an atom or a molecule is the same number as its relative atomic mass or relative formula mass in grams. So hydrogen has a relative atomic mass of 1. If we have 6.02 times 10 to the power of 23 atoms of hydrogen, we know that the mass of this amount is the same as hydrogen's relative atomic mass in grams. So in other words, 1 mole of hydrogen weighs 1 gram. Let's do another example. Ethanol is a compound with the formula C2H6O. To find the mass of 1 mole of ethanol in grams, we find its relative formula mass. 2 carbons, that's 2 times 12, 24. 6 hydrogens, that's 6, and 1 oxygen, that is 16. Add this up, and the relative formula mass of ethanol is 46. The mass of 1 mole of a compound is the same as its relative formula mass. So 1 mole of ethanol has a mass of 46 grams. And we can also refer to this quantity as the molar mass of ethanol. We're going to go a bit further here and introduce a formula that you can use to work out the number of moles for a given mass of a substance. So say we're given the chemical formula for a compound and we're told that we have X grams of that compound. From the chemical formula, we can work out the mass of 1 mole of that compound, which is just the same as its relative formula mass in grams. So by dividing the given mass X by the number representing 1 mole, we can work out how many moles we have, or how many moles of X we have. So if we look at an example here, we're asked how many moles in 12 grams of ethane. So we're given the formula for ethane. If we work out its relative formula mass, we have 2 carbons and we have 6 hydrogens. add these numbers up, and we have a relative formula mass of 30. And therefore we know that 1 mole of ethane weighs 30 grams. Now we're asked how many moles are in 12 grams. So we divide 12, which is the mass of the compound that we're given, by 30, which is the relative formula mass, and we get an answer of 0.4. 12 grams of ethane is equal to 0.4 moles of ethane. So that's the most important part of this video. Now I know the question doesn't ask this, but what if we wanted to find out the number of actual ethanes in 0.4 moles, the actual number of individual ethane compounds? Think about how you might do this. All we do is multiply the number of moles, which is 0.4, by Avogadro's constant. Zero 0.4 times 6.02 times 10 to the power of 23 is equal to 2.408 times 10 to the power of 23, which is still a huge number. So I hope this is making some sense at this point. In case it isn't, I'm going to finish off this video by summarizing 3 very useful formulas to be used in calculations should you need to use them. The first formula is the same one as on the last page. If you're given the amount of a compound, or the amount of an element in grams, and you want to work out how many moles it is, you simply divide the mass that you're given by the relative formula mass to get the number of moles. The second formula is a rearrangement of the first. If you know the relative formula mass of a compound, and you are told how many moles of that compound you have, just multiply the 2 numbers together to get the amount in grams, if that is what is being asked. And finally, we've gone through an example on this last one, on the last page, and it's working out the number of particles for a certain amount of moles. You don't even need to know any formula masses or anything for this one. Just multiply the number of moles by Avogadro's constant and you will get your answer. And that is because this number represents, or this number tells you actually, how many atoms or how many particles we have in 1 mole. So by multiplying by the actual number of moles that you have, it will give you the real number of atoms or particles that you have in your substance or your sample.